Ones that are going to be used in the steam boiler. So the very important one is this one, our 159. So all the numbers, like even if you got a different company, it wouldn't really matter. What you look at is right below that. So this one is the oxygen scavenger, and the chemical itself is sodium bisulfite. So this chemical goes directly into your feed water tank and helps eliminate oxygen in the feed water before it goes in the boiler. Because if there was any oxygen that would go from the feed water into the steam boilers, it would start to pit the copper tubes and start to have corrosion inside the boiler itself. So you pre-treat the water with this to make sure there's no oxygen in it. This pump feeds, Mike had told me, based on the makeup water meter going into your DA tank. So it's very efficient. So that way you can meter the sulfite levels by changing this pump. So this pump is constantly getting feed from, I think it's from the controller. It's talking to it and saying, okay, we've now added 100 gallons of makeup water, feed for, X number of seconds, feed for 10 seconds.
So self-adjusting.
Yeah, so if you need it, if you saw, sulfite levels, I'm sure when you do startup and you have normal operation, they'll get better over time, but in the beginning, you're probably gonna see these levels really high or really low. So you'll make small adjustments to this pump here. The large knob is the stroke, so how much goes in for every pump. The smaller knob is the speed, so how often it pumps. It's usually better to make adjustments on the smaller knob, otherwise this pump could lose prime and then it won't be adding chemical. But with these type of lines, it's usually pretty easy. So you got stainless steel lines and these fittings here. You put black tubing on here so it's resistant to the sun and everything. This all should be fine, but yeah, small adjustments on this pump to change the sulfite. So the other chemical that goes in automatically based on that same makeup water meter is this one, our Garratt-Callahan 485. So this one is a steam lime treatment chemical. There's a lot of different kinds. So you can look on here and see that this one is diethylamine cyclohexamine. So this type of chemical is meant to protect your steam condensate system. This chemical will coat the steel pipe to prevent corrosion, and will also increase the pH of the condensate. So low pH, you can think acidic. It'll start to eat away at the steel pipe, possibly even the plastic. Higher pH, you're in range, more neutral, around like, neutral is 7, but this is usually gonna be around 8 for the steam condensate. So same thing, this feeds based on the makeup water meter. We're making an assumption if you're using feed water, then you're creating steam, so we need to add more chemical. This chemical typically is injected directly into the steam header coming off of the boilers. So this chemical actually goes into the steam and then travels throughout the entire system. So even if you had steam being used down in the basement or your condensate receivers going out to the sewer, this chemical will travel with it the whole way. And same thing, small adjustments made here based on your testing. So that one we're going to test the sulfite to make sure in the feed water and the boilers. This one we're just going to test the steam condensate to ensure the pH is in range. Small adjustments, since it's automatic, this is such a nice way to have the system. It feeds automatically, make adjustments here for that. The last chemical, this one actually is fed separately into each different boiler. This is our alkalinity booster. So this one is a chemical with a very high pH, sodium hydroxide. So you're going to test the alkalinity. Alkalinity you can think of as the chemicals that come naturally from the water and then cycle up in the boiler system. So there's a certain level of alkalinity that's good. Way too high, you can have scaling. Too low, it can be corrosive. So based on your testing, you'll also adjust each one of these individual pumps. And the way that Mike had this wired is also very nice, is that each plug here is tied into the boiler in there. So if each individual feed water pump kicks on, it will add for each individual pump. So very easy to dial in each boiler. So yeah, same thing, small adjustments here will add more or less chemical based on that feed water pump going in. And typically for all of these, it's not very much, very small amount of chemical as the boiler is running and calling for feed water. But yeah, this one is our alkalinity booster. Any questions so far about the chemicals? We got sulfite for the oxygen scavenger going into the feed water, amine going into the steam header to raise the pH of your condensate, and alkalinity to go directly into the boilers to also prevent corrosion. Any questions about that stuff? Yeah, pretty straightforward. This is a wonderful system that Mike set up. It makes it so easy for operation in the future for you guys. Yeah, that's about it. I mean,
speak on the dangers of each chemical,
yes.
either on your skin and or the roofing materials.
Yeah, so the drums that you see here are actually a drum within a drum. So inside here is a 40-gallon drum. On the outside, it's like a 55-gallon drum that it sits inside of. So most of them are not that hazardous. Like, they will have a strong pungent smell, so you wouldn't want to put your head straight in there. But in order to check the levels, you're gonna have to come up here, open the containers, and take a look inside. So you can see kind of the white crusties that build up. That's all pretty normal. You can see the tubing also is somewhat discolored. It is, well, it's black tubing. All these fittings should probably be tightened up eventually. So all of the, the tubing will sit inside the drum. Typically once a year, once every 2 years, Ben or Mike or you guys will replace that tubing to make sure it doesn't crack. The most important thing I would say about this chemical, it will make this plastic tubing brittle. Like, you can feel it right now. It's all pretty pliable. But you'll feel over time, especially with the sun exposure you're gonna get here. I might even recommend, I'm sure Mike's probably talked about putting a doghouse over this.
Yeah, we'll also put that on a PM to check that and maybe replace it once a year.
Yeah, and all these fittings here, you can see how these are all pretty loose. With the vibration of the pump, that will start to loosen those plastic fittings. But anytime you're working around this, I'd highly recommend full face shield and full gloves, because if these kick on and the tubing breaks, it will shoot chemical onto you. And if you read the MSTS sheets in here, which is very important, it will show what hazards we have. All of our chemicals up here, I believe, are corrosive. They're hazardous if they get on your skin. They're hazardous if you inhale them. So the most important thing would be, if you got it on your skin, to get to a hose and you want to flush your skin for about 15 minutes or more to make sure you're getting that chemical off. And 15 minutes, believe me, is a very long time. If it gets in your eyes, it's the same thing. You want to make sure that you get to the eye wash station and you're going to flush your eyes for at least 15 minutes. You're in a hospital, but even then, I would still flush your eyes for 15 minutes and then go seek help, or have help come to you to get you out of there. Because I know people that have gotten this chemical specifically in their eye. At 44 Montgomery, the doctor told him if he hadn't flushed for 15 minutes, he would have lost his eye.
Yeah, looks like we need an eye wash station out here, guys.
Yeah, I'd put that on the punch sheet. Get them to do that, like a real eye wash station too, with the shower. Especially since they're outside, believe me, this tubing will get brittle. Even though it's black, it's UV resistant.
Can we replace that with a different material? Or do you recommend?
I recommend how it is.
Pipe?
It's possible. I'd ask Mike if he recommends that. I think that the plastic is good, just for it's easier to get it to prime, easier to get it to pump, and the black will last a very long time. But if you're ever working around any of the tubing, making adjustments to this stuff, face shield and safety glasses. So even the glasses like you're wearing there, it's good if you had like side shields to put on them, because the chemical that got on this guy, he was wearing safety glasses, but it was one drop of chemical went behind his safety glass and went straight in his eye. So that's why face shield is definitely recommended. Glasses.
Rich, can you make a note? Eye wash station, check plastic tubing. So when we add this into our PM system,
I mean, eye wash, definitely.
For sure.
Should be.
Body wash.
Yeah, shower would be good too. Yeah. Could be used, for other purposes too.
Hot days.
Yeah. Beautiful day up here. But when I think Matt, our driver, can come straight up here, which is really nice. When he transfers chemicals, he's going to come up here and he'll actually put the chemical into each one of these drums. So you guys actually don't have to handle 5-gallon pails or moving chemical into the double containment drums. Nice about having a roof elevator. Is that really simple?
Isn't that nice?
God,
elevator
great.
To the roof?
Yeah.
Rare.
Yeah.
Well, they were going to build another floor. They ran out of money.
Oh, shit.
Lucky for us.
Yeah.
When they were after they started the initial build.
That's great.
So if the chemical does get on the roof, 15-minute rinse on the roof as well?
At least, yeah. So in
Any
the
soap,
MSDS
any
sheet,
soap materials at all? Just kind of rinse it, dilute it, basically
typically it's dilution. If it's a large spill, you're actually going to want to contain it and absorb it with kitty litter. But read the MSDS sheet before. Each one has usually different properties.
Okay.
They're all
Yeah, we're going to end up laminating these and putting them on.
Yeah, because all these MSDS sheets are now referred to as safety data sheets.
Yep.
So they all
No
have,
more MSDS, it's just SDS.
yeah, SDS sheets.
Correct.
So they all have a universal numbering system for the sections, and one of them is about spills and containments. Yeah, so you can see like the precautionary statements here. So in the triangle of how you read that, so 4 would be the maximum. Like 4 for flammability would be like propane. Or diesel, you know, would be, gasoline would be 3, fairly reactive, diesel would be like a number 2. Instability, that one, typically all of ours are very stable compounds, but the health hazard is a big one for all of these. They will cause harm and possibly even chronic harm if you are inhaling them on a regular basis. So it'll list the most hazardous chemical in it, or what so this one's mainly sodium hydroxide. You can see it's 25%. All of this is listed, registered with EPA, registered with OSHA. So if you called our office, or if you called, there's a number on here, or is it this one? So if it was a 24-hour emergency, you can see here, this Chemtrek company, if you said, hey, I've got Garrett Callahan Formula 1156, they can pull that up, they'll have this exact sheet, and they would be able to help you, you know, even if it was 2 in the morning and something had happened. Otherwise, you can call our office and they can help you there. So here's in section 4, this is the first aid measures. So you talk about eye exposure. So if it's in your eyes, minimum flushing in 15 minutes, call poison control, inhalation, ingestion, because some of those are different as well. Some of these also, like for clothing, like I think for your closed loop chemical, the 12L, it'll say discard your clothing, because it'll actually start to eat away at the cotton or eat away at leather, like on your shoes.
Yeah.
And you can use
it's
it.
It's a Ricky Bobby moment. You're going to be stripped down naked, running on fire.
Yeah.
It's a long way to the shower in the pharmacy too.
Yeah, yeah. Okay, so here in section 6, accidental release measures, talks about, you know, uncontrolled, a small spill, mop it up, absorb with material. And that material itself, though, can actually become hazardous waste, potentially, but it would list that here. So larger
solid
spill.
waste is a lot easier to dispose of than
Yes.
liquid waste.
Yeah. And they will, some of them will even talk about if they were to have a higher flammability rating, it would say, you know, do not use sawdust, for example. Use a non-flammable inert material such as kitty litter. Even like the most expensive spill kits, sometimes there is special kitty litter. Yeah, but reading these, you'll see that they're pretty similar for all of our products. Similar for probably a lot of stuff you would use here in the hospital, actually. You know, Simple Green will have the same style sheet that you see here. I think that's all I can really think of for this. Yeah. Yeah, but good to read up on these. Also know that, yeah, these are the placards. They'll just give you a quick idea of what you have. The MSDS sheet will give you, or the SDS sheet will give you the full information about safety, handling, exposure to yourself. Okay, so the other one is controllers. You've got nice automated controls for your steam boilers, which is not common, but fantastic, because it means you don't have to come up here, you know, every 4 hours and do a blowdown. It'll be all done automatically. Here, Ben, can you put that back on there? We'll go inside and take a look at the controls. Those are inside, right?
Yep.
Can you go over like this knob? Do you guys do anything?
Those are the priming knobs.
Okay.
So when it's closed this way, that means the chemical is going through the system.
Mm-hmm.
So if for some reason it's not primed and it's not going in, you turn it that way and it opens it up. So then it just comes back and it feeds right back into the drum just to get the prime going. So usually you want to turn the pump way up, open that up. You know, maybe the foot valve down there is clogged or something. So you'll shake that, try to get it loose, find out what your problem is. And then once you see it flowing back this way, you'll close the knob back up, and then that means it's feeding into the system.
So that's how we confirm that you do this prime by opening that and then watch it prime.
Yeah,
back.
exactly. You'll see, and then prime just folds right back.
Got it.
All right, so this controller here actually operates for all of the boiler systems, I believe. It's coming from the backside and up there. I think it's coming from the back valve.
Medium pressure steam.
Alright. Alright, cool. So this is the main screen that you're going to see. So you can see up here where it says System 1. So that's, and then if you scroll up or down, you got System 2, System 3, and System 4. So what it's reading out there is the conductivity, so the total dissolved solids of the water in each one of these boilers. So how these boilers work is, you've got feed water that comes in, you're creating steam, so the water is leaving, but actually the minerals in the water, calcium, magnesium, that alkalinity that we talked about, those stay behind. So they start to concentrate up. So there's an ideal level where we have good protection for corrosion and water savings and heat savings. Too high, you can have scaling. And you would see in a steam boiler, if you did not blow a steam boiler down, you would see scaling start to occur almost instantly onto your fire tubes. And so those fire tubes would start to develop a thin layer of scale on them. Even a small layer of scale, like 1/10 of an inch, can cause your gas usage for that boiler to go up by like 10%.
And then once the scale forms, it grabs more scale that much more quickly.
Yeah. Yeah. So if like you can imagine, I like to kind of scare people about these because they are dangerous. In old boiler plants, if you had a steam boiler that wasn't treated, imagine that scale builds up and up and up and up. Eventually you have almost nowhere for that water or fire to go through. Well, if the boiler doesn't have proper safety controls, the boiler thinks, fuck, I'm not making steam. Full fire. It'll go full fire, hottest, the stack will almost catch on fire, like so hot. And if there's no water flowing through there, they'll start to get hotter and hotter and hotter and build up pressure. If a little bit of water gets into that, all of a sudden you have a bomb. So that water is going to expand, and this is 50 plus years ago, they'll explode. Modern boilers have controls to not allow that. They've got low, high fire, maybe variable. It'll have low water alarms as well, so it'll cut the gas. So a lot of that can't happen, but still for proper maintenance, you want to have automated blowdowns or manual blowdowns, and I'm sure Mike will recommend doing manual bottom blowdowns, on a PM schedule maybe once a week. Because what this boiler is doing is just removing water off the top of the boiler to bring in feed water. The bottom blowdown there, that actually allows you to remove sludge out of the bottom of the boiler. So that mineral, scale, excess chemical, yeah, that will actually start to build up. And if you're doing everything right, there will be sludge at the bottom. The bottom blowdown, when these boilers are on, you'll see it'll slam it out and remove all of the sludge off the bottom. These are great to have automated controls on. Otherwise, you'd be up here doing manual blowdowns every 2 hours sometimes.
It's
for emergency. Yeah, exactly. Because the other thing, so you imagine when you do a blowdown, you're not only removing water and those minerals, you're also removing the heat that you already added into the boiler. So essentially, you're blowing energy down the drain as well. So the less often you have blowdowns, or the smaller the blowdowns are, the more efficient these boilers will run. That's the beauty of automated controls. You'll actually end up saving gas, saving water, and saving chemicals because it's all automatic. All right, so all of this is automatic. So let's just look at the first one. I'll look at 2 because the connectivity is up. So you see the connectivity is 1,572. And these things are set to test. I think Mike has it set to test probably every 30 minutes. So what that means is, if you look over there, typically there's a solenoid valve that will open based on the controller. It'll open the sample. So it'll have a sample time, which is, you know, like 5 seconds. It'll shut a valve so that it fills an area with water that has the conductivity probe. So that automatically checks the conductivity. If it's high, it'll continue to dump water and then stop, and then test it like every so often. If it's too low, or if it's in range, it will stop the blowdown and just go back to running its normal cycle. So yeah, testing every 30 or 40 minutes. We'll see how Mike has it set up. Okay, so if you hit setup run for each individual one, that's how you change the settings. So we've got set point here, and here, oh cool, that's awesome. So system 1, system conductivity, and you can see the sample method here says sample and hold. So set point 4,000, your differential is 300. What that means is when it gets up to 4,000, it will blow it down to 300 below that. So it'll blow it down to 3,700. So that will be kind of the dead band. So when all these boilers are in normal operation, you'll see the conductivity anywhere between probably 3,500 and 4,000. And it'll just ride in there. And a very, like if you curved it out, it'll show a nice little curve without these big swings. You're not going like 4,000, 1,000, 4,000, 1,000. That's where you get the efficiency. Less blowdowns, you keep it near the limit. Okay, so he's got a high alarm for 4,200, which will just display, it'll flash. A low alarm at 1,500, and then here's the sample. So sample duration, he goes every 2 hours, and hold time, so it holds it for 2 minutes, and then it blows down for 10 minutes at a time. So it'll dump for 10, stop for 2, test, and then blow down for 10 more if it needs to. So you'll see it'll go through a cycle like that. I'd be excited to see when the thing actually works. Like, that would be cool to watch them all work at once too. Hold, blow down, hold, blow down. So instead of in, not the old days, in most boiler plants we work in, that would be you doing that work. It'd be you up here, grab the sample, test it, shit, okay. Blow down, blow down, blow down, blow down. All right, come back, test it. Okay, I need to do it again. This thing, it's gonna do it at 2 in the morning, 2 p.m., it'll do it all the time.
I'm noticing we're not on e-power either. I'm not looking into that.
Oh, for the boilers? Okay.
The controller, please.
Yeah. Yeah, so Mike set this up. He's the one that programmed this. And all of them are going to have exactly the same. He will probably be the one to make changes if needed. So for example, if that blowdown of 10 minutes is too long, if that's too long, then he'll change that to a lower time. Or if it needs to be higher, he'll increase that. But Mike will make these changes. I'm sure he'll let you know.
As we start running, he'll kind of start tweaking it.
Yeah. But the set point that he has there, 4,000, and the differential of 300, that will probably remain the same. Because 4,000 is a pretty ideal level for efficiency of chemical, water usage, energy, and then being away from that scaling potential. Yeah, each one of these, so if we go into like system 3, you can see exactly the same settings that Mike has.
You guys ready to do this?
Okay. Calibration. So each one of these probes can also be calibrated. That's something, again, that Mike will probably be doing and maybe work with you guys to just show you how it works. That'd be if you test with your meter compared to what the system is reading, what the controller's reading.
DeAndre to engineering, I need the key for the boiler room.
Okay, cool. Okay, so the other one is under here, under timers. So this is how it feeds chemical for the sulfite, the 159, and the amine, the 485. So you see here it's based on pulses. So that's reading a pulse from the water meter. So every time the water meter is spinning around, typically it's every 10 gallons or every 100 gallons, it sends a pulse to the controller and it counts that. So here, for every 20 gallons of water, it will feed for 15 seconds. Yeah, so for every 20 that the makeup water reads, it'll feed chemical for 15 seconds. Again, that's a setting. All right, no problem. That's another setting that probably Mike will work with you guys to dial in and get just right. But to me, that, you know, Mike set these up before, that should be perfect.
Yeah, I'm gonna need to borrow your keys so they can get access to the boiler room.
The same. Yeah. Yeah. Yeah, cool.
10-4, you got a ticket to come down to the shop? 10-4, en route.
I saw a password in there. Are we password protected on?
It's not right now. That'd be up to you. And on these, you can actually have like different users as well, or an admin password, so nothing could be changed if you'd like, you know, each individual person. Water meter, just to show you where that one. So this is showing the total amount that it's actually gotten. So yeah, the contact value, one contact is 10 gallons. So as it goes. Yeah, I think there's just that one meter. So he's got it set up so even though there's multiple systems, it has just one system doing that timer. Because it adds chemical for the amine and the amine and the sulfite, regardless of what boiler's running. Yeah. Cool. All right. Any questions at all?
Yeah, I'm curious. You say that that 591 is the conductivity.
Yeah. Yeah.
And you said that it was set at 4,000 and dropped to 3,700, but the low was 1,500.
Yeah.
Are we seeing that? Why are we not seeing an alarm?
I think
on that, or where would we see that alarm?
That alarm, so you see where it says system okay? Oh, just what it's alarm. Oh, there's system low connectivity.
No connectivity.
So that's, I think, for each individual one. So I think the way Mike probably has it set up now. Yeah, so there's the one alarm.
Okay.
So you can scroll through each one. So yeah, this one's at 1,500, so it's
above
the low.
Above them, so it's okay.
Yeah.
But that one should be in low alarm as well.
Yep, yeah, low alarm. Yeah, that one's low alarm.
And is that right now just because the boilers aren't doing anything, because nobody's using the steam, and they just haven't had a chance to get balanced?
That's correct. So like the water that you're putting in is from the water softener, so there's almost no hardness and no conductivity at all. So it will take a while before it builds up, which is a good thing. You want to be using that low TDS water to feed the boilers, but it will take a while before they do cycle up.
Right.
So what if it's possible, I'd recommend like staging them as you go into normal operation now, to have like one of the lowest conductivity run first if you could.
How do we go about setting up staging them?
That would be based on the boiler controls, actually, not for the water treatment.
Okay.
So I don't know how they probably have it set up.
That's part of the BMS.
Yeah, I'm guessing they on these newer ones. A lot of times they rotate weekly. You know, it goes like 2, 3, 4, 1. Next week it's 3, 4, 1, 2, etc. like that. Yeah. So that would be a way. So it looks like one was or two.
Yeah,
was
they canceled our steam boiler training yesterday, so we couldn't get in the building.
Okay.
So we would have learned that probably yesterday, or it could be when we do the BMS.
Yeah.
They're going to tell us what they have everything.
Hopefully they have that tied in the BMS. Yeah. But yeah, this is a great system to have it all in one. Otherwise, you'd have 4 different controllers here,
right,
doing the exact same
awesome.
shit. Yeah. Cool.
Yeah, pretty much we don't touch it. We can just monitor it.
Exactly.
There's nothing we should have to really do.
So for you guys, and I'm sure Mike will have what he was going to recommend, steam boilers, especially in your case, since you're a hospital that has 24/7 operation, probably test twice a day, potentially, or 3 times a day, depending on how your shifts work. A lot of times with boilers like this, once a shift would be good. I mean, or even coming up and checking conductivity once a shift would be appropriate, just to make sure that the controller is working. In the future, I can almost guarantee you, it'll be a hell of a lot easier because we'll be able to completely rely on the controller. But still doing daily testing, I'm sure will be necessary. Because you know, the controller can't test the sulfite level, it can't test the alkalinity level, it can't test the pH of the condensate. So that stuff is still And even if there were automated systems, we'd probably still recommend doing human being manual testing of those different systems.
Okay.
Yeah, this is nice. And that's just your quench tank. Busting our way over there. When it blows down, I'm sure I don't know if you've heard it, but that thing probably rages. Yeah. All right, any other questions? Clock. This is probably the DA chemical going right here. Into there, and then the amine. Looking for where the chemicals. So you can see like the blue handle tape out here on each one. That's where the alkalinity chemical goes in each boiler. This one right here, that's where the steam amine chemical, the 159, goes directly in. Or sorry, the other sulfite chemical. Amine's probably going up into the header.
Right here. Goes in right here. We have that feed and this feed. These are the two feeds.
Yeah, the burner's on right now.
You can try it?
Yeah. Or we could try doing it for number 2, or no, yeah, this one's on. Do this one.
Where this one? Right here. Go outside right here? It should go outside. Eventually, yeah. That's over here, right? Okay.
Yeah, so that's what the sludge is going to look like. It's going to look like mud. So you just do a quick one?
No, I didn't do it yet.
Oh, this is probably just what was in the line.
Yeah, I don't even know why they had the valve closed with the system running. It's not really a good idea.
Well, especially, yeah, with the automated controls.
Right,
Yeah.
right.
Well, it's good to go now.
And this one right here, the junior, now you want got a coupler?
Not yet.
Huh?
It will eventually.
Yeah, that looks pretty bad.
Yeah. The valve is closed.
It's nice to be able to actually see it though. You know, in our other building we can't see it because it's behind all the feed pumps.
Yeah.